Hey everybody, my name is Rich Baird. I'm the TA for 2210, and today I want to give you a quick demo on how you can go from a schematic that looks something like this to an actual implementation on your breadboard. So I'm going to take you kind of through my process. Everyone's process is a little bit different, but hopefully this gives you some idea of how to start. So let's go ahead and get started. All right, so the first thing I like to do when I'm looking at a schematic like this is I like to highlight the nodes so that I can see what is connected to what. I sometimes have a hard time telling when things are in series and in parallel. Now, in this particular circuit, that's pretty straightforward to see. It's been laid out quite nice, but sometimes that's not the case. So I think this is always a good step. All of these. Oh, okay, you can still see that. All right, and I will use yellow here for power. Okay, great. And then let's see, let's choose some other color hues here. So you can see I'm highlighting everything that is electrically connected. So all of this wire here is electrically connected to all of these resistors. These resistors are electrically connected and also goes all the way over to here, and so on. Now I don't worry about things like this section over here, for example, this stuff right here isn't really my concern because this isn't a node. A node is where multiple connections come together. These are all in series. It's very easy to tell this is connected to that, is connected to that. So I don't worry too much about those. Okay, so now that I have this highlighted, I can tell right now that I have my resistors connected. I have R3 and R1 connected to V1 on the positive side. And then I have R photo connected to the negative side, R2 connected to the negative side. I have the negative end of the op amp connected to ground, and I have the anode of the diode also connected to ground. So with that, now that I kind of can see what's going on here a little bit, let's go ahead and start putting this on a breadboard, and I'll show you what that looks like. Okay, so I've gone ahead here and swapped so you can see my breadboard. And the first thing I want to point out to you is that right here, these red lines and these blue lines here are provided for our power and ground. So everywhere where this line spans, the pins underneath it are electrically connected. And the same case here for the blue ones, the pins above it are electrically connected. Now, and you'll notice that here it's broken. There's not a line connecting here. That means that these sections here are not electrically connected. So again, all of this is red, all of this is blue, all of this is this red up here, and then under here is this blue, and then these also are separate. So these reds are not electrically connected unless we connect them, and same for these blues. So these are what we call power rails. They give us some convenience in connecting things to power. Hi, it's Rich from the future here. Something that I neglected to mention when I was recording this is that everything in a single column here is also electrically connected. So I mentioned how these power rails are connected, but everything in one column, for instance, everything over here in 35 is going to be electrically connected And so if I plug something into this column 35 and something into another space in the same column, it is as though I connected them directly to each other. There's no differences. So that you're going to need to understand that to understand why I start plugging things in where I do. Important also to realize that if I move to a different column, so I do like 35 going to 40, these are not electrically connected. So if I move over to a different column, these guys here are not electrically connected. So everything in a row is separate. Everything in a single column is connected. Okay. Sorry, that'll be helpful for you. Sorry, I forgot to mention that. For this circuit, now I'm going to go ahead and use this rail here for my power and ground. And we'll see if I think I need a little more space, I can always connect. So the first thing that I do is I haven't connected the battery. That's the last thing I'm going to do. So I'm going to just assume that this red line here has power positive, and this blue line here is my ground, power negative. And I'll connect everything as though there was already a battery connected up in this way. All right. So what I want to do is I want to look at what is connected to what. So R3 has a direct connection to the battery, and R1 has a direct connection to the battery, and the positive end of our op amp has a direct connection to the battery. So all of these three things need to be connected directly into our positive source here. So let's go ahead and do that first. So it's always good to have the components that you're working with on hand. And speaking of which, where did I set? Oh, it just came over here. Yeah. So these are the components we'll be working with. We've got a couple of resistors, an LED. This right here is a photoresistor. I don't know if you can see that, but that's a photoresistor. And we have an op amp. This actually has several op amps in it. Let's be using one of them. I'll explain how that works in a minute. So let's go ahead here. I've made a little notation on, I don't know if you can see that, but I've made a little notation on the circuit right here. That says 1K, this is 1K, this is 2K. Now the reasons that these values are chosen has to do with how the Wheatstone bridge operates and the maximum resistance of our photoresistor. That will be discussed in the lab. For now, these are the values that we're using to construct the circuit. All right. So I have a 1 kilo ohm resistor here. This is about 1K. And I'm going to go ahead and connect it directly to power. These have some longer leads, so I'm going to give it some space. I'm just going to kind of work it into that hole there. If it gives it a little resistance, don't shove it in, just kind of give it a little bit of working. It'll go in. Okay, so there we go. Same thing here. So this is going to be our R3. I'm going to go left to right. So this I will call our R3. Now I'm going to put in R1. And connect it to the same positive line. Remember that everywhere where this red line touches is considered the same. So this would be equivalent to connecting these two, this would be equivalent to connecting these two directly to the positive end of the battery. Okay. Now I have an op amp that I have to place. The pins on this op amp, this is called what's called a dip style chip here. And it's specifically designed to straddle a breadboard like this. So now there we go. Now I happen to have the data sheet up here, so I'm going to pull this up. I'm looking at the data sheet here. I see that this pin right here is my output pin. So this guy right here is output. This one right here next to it is the negative input, and this one right here next to it is the positive input. And then I have the right next to that, this guy here is our V negative or V positive, and on this side opposite is V negative. So let's go now. We know that we want our inverting or our negative input to be between R3 and a photoresistor, and we want our positive input to be between R1 and R2. So probably the easiest thing to do is to leave this here, and let's go ahead and connect up our photoresistor and our R2 components so that we know where those are going. Okay. So now that we have our resistors in place, we can start looking at how to connect up our op amp. That's this guy here. Okay. So as I said before, the output is right here, far left. The negative input is the next one over. Positive input is the one after that. And then the power rail V positive goes here, and V negative on the corresponding pin on the other side. So output, let's go ahead and handle, we need our 100 ohm resistor. That says 150 ohms. 100 ohms is also acceptable. So there's our output pin. Connect it right in there. And I'll go ahead and bring it over to the other side, so I have a little more space to work with. Okay. Then I need to connect my LED. The longer lead is the positive side. So we will stick the positive side here. And for convenience sake, I'll go ahead and bring the negative side over to this blue line. Now, you'll remember that I told you that these blue lines are not electrically connected, so let's go ahead and fix that. To do that, we'll just need a bit of wire. Now our grounds are connected. Almost made a big problem there. Now our grounds are connected. Always double check. All right. So the inputs go between their corresponding resistors. So again, what does that mean? Well, let's look at what that means. That means either this end of R1 or this end of R2. It should be the same. So we'll go from here, because remember, this side here is our positive of R1, and this side here is our positive of R2, and either one will work. They are connected after all. So we'll grab it from here, and we'll bring it over here. Okay. And then last, we have our negative, our inverting input. There we go. then lastly, now we can add the power rails here and here. So our V positive and our V negative. Grab a shorter red wire here. Now, our V positive is right here. Remember that this whole column is electrically connected. And we're just going to go ahead and bridge that over to our V positive right here. Okay. And our V negative, our ground, is going to be on the same pin on the opposite side. So this is pin 4 on this side, so it's pin 4 on this side. You know what? Rather than doing that, I'll just flip it around. Then I can actually see what's happening. There we go. Count that just to make sure. 1, 2, 3, 4. That's the one. And now all we should have to do is attach our power supply. So let's go ahead and do that. Then we can test this out. So I've gone ahead and connected my power supply. I'm going to move the iPad screen over to the right, to the left here, so we can see a little better, and show you kind of what's going on. So so right here are the leads that are going to from my power supply. This yellow one is negative. This red one is positive. And then in order to make that stretch, I connected the power rails together. So that's what this big loopy red wire is doing. It's just connecting these two power rails together. This one here and this one on the other side. And then the grounds were already connected in the same way. So the yellow one is going to this ground over here. Hopefully you can see that okay. All right. I have one of my wires connected incorrectly, and so it wasn't working quite right. There's actually this little red wire here, if you can see it. I had it connected into the column next to this resistor. I'm pointing, you can't see over my finger. This wire here, this red one, I had this end connected over into this column instead of this column. So you can see that there would have been no connection there. That was causing a problem. So you can see the LED turned off. I move it, the LED turns on, off, on. So that's how it's supposed to work. Okay, so now that was just a quick introduction into how to go about converting a schematic into something that you can actually build on a breadboard. And really it just comes down to knowing what everything is connected to. So just understanding what all of these guys are connected to and understanding the rules of the breadboard. So to review the rules of the breadboard, these columns are all these columns over here, you can see, are all electrically connected. These rows are not. Okay. Everywhere above this blue line here, or everywhere right next to this blue line, is connected where the blue line touches. And same thing for these red lines. To connect different points, you can use wires to bridge them. And then just pay attention to how everything is getting connected. All right, I hope that helps some of you. I look forward to working with you throughout the semester.